So now I'm back and I'm finished plotting my points and my graph looks like this. So now that I'm done plotting, I know where my points are going to be, and so I should be able to give myself, now that I've done them, I can see where my points are, so I can put my graph, the title in without disrupting any of the points. So because I have atomic number on the x-axis and atomic radius on the y-axis, I need to incorporate those two into my title and give maybe a little bit more information. It's not like I'm plotting the entire periodic table, I'm only plotting the first 40 elements, so I can say that in my title. So let's say atomic number versus atomic radius for the first 40 elements. And let's underline that to show that that is the graph title. Okay. And my graph is not done yet, so let's refer back to the instructions here. So, oh, sorry, I've turned up the brightness here. So I'm done this for atomic radius. Now I need to write in the element symbols for family 1 and family 18 elements on the graph above each of the corresponding points. So if you're not sure which elements group 1 and group 18 are, you can refer to your periodic table. So group 1 elements are along here. So hydrogen will get a label, helium will get a label. Sorry, I mean, it will, but hydrogen will get a label, lithium will get a label. Sodium will get a label, it's down here. Potassium is, where's potassium? Potassium is number 19. Oh, potassium's right here. So that'll get a label. Rubidium will get a label, that's the last one. Well, the last one of the group 1 elements that we graphed. Now let's look at group 18. So of my group 18 elements, helium gets a label. So yep, helium gets a label. Neon gets a label. Argon gets a label. And krypton, just down here, will get a label. So those are all of my group 1 and group 18 elements. So now let's put the the symbols above the data points. So hydrogen will be the first to get a label. Oh, sorry, you can't see that. So there's hydrogen here. Then helium is number 2, atomic number 2, oh, He. Lithium is next, that's atomic number 3. Then neon, which is atomic number 10, so 10 down here. This one here will be our neon. Okay, sodium is number 11. So going up to number 11 is sodium. Then argon is number 18. Argon. Potassium is number 19. Next one over. Potassium is all the way up here, so it's potassium. Next one is krypton, and then rubidium, so 36 and 37. So we're all the way over here, 36 is krypton, and then 37 is rubidium. Okay, so I've done now step 2 for this graph. Number 3, Draw a vertical line, so from top to bottom of the graph paper, through each family 18 atomic number to show that you're at the end of each period. So I'm going to draw my line through each of the group 18 elements. So helium gets a line through it, neon, argon, and krypton. Those guys are all going to get a vertical line through their atomic number. So helium is going to look like this. Okay, so that shows that that is the end of period 1. Not a very big period. Okay, neon gets a line through it. Okay, argon is going to get a line through it. Okay. And then the last one is krypton. Okay. So now this is what my graph looks like. And let's see what is next. So I've done number 3. Now I'm going to draw a smooth curve for data in the same period, but do not connect data points for elements in different periods. So in other words, don't connect family 18 points to the family 1 point for the next period. So remember that these lines show you the different periods. So what this is saying is you want to draw a line for elements that are like in between this line and in between this line and in between this line, but you don't want to connect like neon to sodium, for example. So I'll show you what that looks like. So these two, because there's only 2 points here, we can use a ruler to connect them. For the other ones, we will not be using a ruler. So these ones, I want to draw a smooth line through them. So again, you're not using the ruler and you're not connecting every single data point. You're just drawing a sort of swoop from the top of the period to the bottom. So you want kind of a nice curve like that. Okay, so let's connect sodium to argon. Again, I'm not using a ruler, but I'm doing like a nice smooth line. Over here, we kind of have data that goes up a bit and then goes down. So I'm going to ignore that it goes up and down. I'm just going to kind of follow sort of the pattern. Oops. So it's not going to be perfect. Like it's not going to intersect with all of the data, but it should show a sort of overall, for this one at least, downward trend. So again, you're not connecting every single one of the data points. You're just making sure that the top point and the bottom point are connected, and that you have like sort of a smooth line between them. Okay, so there's my finished graph. Out more so you can see the whole thing. Make sure that you've underlined your title. You've used rulers for both of the axes. I'm going to write my name on the back of the paper. Okay. So there you have it. I've done step number 4. Zoom in a bit so you can see. So repeat step 1 to 4 above for both the first ionization energy versus atomic number and electronegativity versus atomic number, and use a separate graph for each. So for the next graph, I'm going to get a separate sheet of paper, and it's going to have, you can use the same scale at the bottom because you're also going to be plotting the atomic number again, but the scale at the side is going to be different. So if you look at your data over here, For first ionization energy, you can see that the values are way smaller. The smallest value here, let's see, looks like it goes down to 0.42, 0.4, so you probably want to start at 0 for this one. And what's the value that it goes up to? Let's see, there's 237, 2.37 I should say. So it looks like the 2.37 value is the highest value there. So just make sure that your values on your on your y-axis, they're not going to follow the same scale. If they followed the same scale, all of your data would be like in this area here, because it's all below 1, or sorry, all below, well, it's all below 5. So you wouldn't be able to see any trends there because everything would be too small. So make sure that you are expanding your scale to fit the appropriate data. When you move on to electronegativity, you're going to need to use your periodic table. So the values for electronegativity, if I zoom in really close here, you can see at the top, the square at the top, electronegativity is located on the bottom right side. So that's that number right here. So you can just write them in as you go. So hydrogen's value is 2.18. Then helium, oh, look at that. Helium doesn't have a value. So that doesn't mean that the value is 0. That just means that there is no electronegativity value for helium. So you're not going to plot that point at 0. You're just not going to plot it at all. So when you get to your noble gases, got helium, neon, and argon. All 3 of those don't have electronegativity values. So when you plot those, it's not that they're 0, they just do not have an electronegativity associated with them at all. So just put a dash in, and on your graph, you're going to, instead of plotting, for example, neon, you're not going to plot it on the graph, you just won't plot it at all. It's not going to be at 0, it just won't be plotted at all, okay? So when you put your lines in, your line's not going to go through any, like, point. You're just going to skip over, so if it was neon, you're going to skip over neon, and you're going to go straight to sodium when you plot sodium, okay? I hope this video was helpful for you. If you do have any other questions, please let me know, and I will make sure to post a picture of my graph along with this video. Good luck!